Hello, hello. Welcome. Good morning. I'm in my garage because it's nice. So I open the garage door and I'm chilling out here and I can get some quietness from my lovely family and I can play on my toys and all that fun stuff. My daughter did this yesterday. Check this out. She did some coloring on the ground. How cool is that? Huh? I think that's awesome. Anyway, all right, to business. So today I started early, started at the beginning of the class, gave you 10 minutes to look over a couple things, decided to start in the beginning of class for a reason. That's because the slides and stuff are very, very short today, but there's a lot of stuff to do. So, for instance, watch a video and then you're typing. So I wanted to make sure. Oh, hi, Leticia. How are you? I miss you, Leticia. I miss your voice. I'm going to have to do a live chat once, a meeting like a WebEx or a Google Meet or a Zoom. Anyway, so we are looking at the slides, right? So again, the same format. You guys click on the slides and you look through them with me. I'll tell you what slide I'm on, and then I'll give you a little heads up. So, yeah, a little bit. No, I'm kidding. Uh, all right. So I'm on slide one, which is lesson 4. How does genetic engineering impact food? We talked about the green revolution, and we talked about GMOs, right? So we were talking about the green revolution was the natural way. And then at the very end of that lecture, we started talking about GMOs, genetically modified organisms. And is that a good or a bad thing? And I told you you'd be writing today, but I wanted to show you a little bit more about the topic before you got into it. So, genetic engineering is the process making GMOs, right? So, GMOs are the genetically modified organisms. And genetic engineering is the practice or the process that creates those. So we're going to go into it, but not very deeply, very, very generally. It is a really, really complex topic. So we're not going to go too deep. I just want you to get the gist of genetic engineering. So I'm on the slides. I'm moving past slide 2 because that's the agenda. I'm moving past slide 3 and 4 because that's the review. I am on slide 5. So the objective of this whole thing is to be able to describe what genetic engineering is. So you should be able to describe what it is. I keep saying describe. You should be able to describe what it is, and very generally. And you should be able to identify the impacts of genetic engineering. So good versus bad, pros versus cons when it comes to making food. All right. When you go to slide 6, and this is why I'm doing this first, and I'll give you a half hour afterward. So on slide 6, there's a video. There's a link down there that says nature documentaries, whatever. You're clicking on that link and you are watching the video for 12 minutes. So you are fast forwarding to 1 hour and 38 minutes and you're watching till 1 hour and 50 minutes. It is a video about, I think they use potatoes as an example, but it's a video of GMOs and it sort of explains the genetic engineering process. It's pretty interesting, actually. I mean, it's kind of cool the way we can change the DNA of plants and food and animals and stuff to get what we want out of it. It's kind of weird. But anyway, this slide 6 that I'm on, if you go into present mode, this always takes a second. It's so slow. Here we go. Here we go. Okay. If you open up slide 6 into present mode, you'll see that those boxes for genetic engineering are empty. So if you click enter, it tells you, it goes step by step. All right. So what are the potential impacts of using genetic engineering? This gives you an idea of how genetic engineering works a little bit. So in this example, and I haven't opened up any of those boxes yet, but in this example, they're talking about corn. Corn has a problem sometimes because caterpillars love to eat corn. So if you get caterpillars in your cornfields, you have a big pest problem. So what scientists do is find a way to make the corn unappealing to caterpillars. So now so if caterpillars try to eat it, they don't like the taste of it. It makes them sick. Uh, and they can do that. The way they do that is they take a gene from a BT, and you don't have to worry what that is, that directs a cell to produce a toxin. Okay. So what that means is there are plenty of plants and animals that are poisonous, that are toxics, right? That are toxins that if you eat, you will get sick. So scientists find some of these plants with toxins in them, a certain kind of toxin that caterpillars don't like, but we're okay eating. And they will take that. So say they find that toxin in some sort of weed, right? So they'll be able to take the DNA, they'll be able to take the gene, isolate the gene that makes the toxin in that plant. And they'll be able to take that gene out. Now, remember, a gene is just a part of your DNA. A gene is the instructions. So we have genes for how tall or short we are. We have genes for our eye color, right? So there are genes in some things that make them poisonous or make them toxic, right? So what we do is we look for one of those, and scientists isolate the gene from that DNA. They literally remove that gene. And now, theoretically, anything they put that gene into, if they can get that gene into something else's DNA, the DNA just copies itself, and the instruction on making poison is in there now. Okay. And when I say poison, I don't mean poison to us. I mean something that a caterpillar doesn't like, whether it's a sour taste or whatever it is. They call it a toxin. So they'll find something, realize caterpillars don't like it, isolate the gene. And then what they have to do is they can't just take that one gene and throw it into a corn seed. It doesn't work that way. They have to join it with another gene, a marker gene, so they know it went in. All right. Because if they put the poison gene into the corn, they don't know if it went in or not. So they add a marker gene to it. All right. And the marker gene doesn't like, or the marker gene can repel antibiotics. Okay. So antibiotics can't kill that marker gene. All right. Just stay with me. The next box opens. Now these two genes that were put together are inserted into the corn cells, plant cells, right, to the seeds. So I take the gene that makes the toxin, and I take the gene that is resistant to antibiotics, and I put it into the corn. All right, I'm clicking the next box, the third one. Scientists then grow the corn cells, right? And after they with one cell, they do this with a whole bunch of different seeds, and they grow the corn seeds. Now they have to figure out which ones have that toxin in it and which ones don't have that toxin in it. The way they do that is they use the marker gene. They add antibiotics. They spray them down with antibiotics, right? Or they inject antibiotics into the plants. And what happens is the ones that it didn't go into, they don't have that antibiotic resistant gene. So they die. The antibiotics kill and break down those plants. All right. So the surviving cells are the ones that have the antibiotic resistance and the toxin. So they keep growing those plants. So those surviving cells grow into corn plants. And then these plants make that toxin inside them. And that toxin ends up killing the caterpillars. All right. So it's a really weird, complex, long process. But what you have to understand is that, okay, we need a gene from this plant because it makes poison. We need to put it into the corn, kill the caterpillars and keep the corn okay. So they take it out, they isolate it, they put it into the corn, they test to make sure it's in the corn, and then they grow it. All right. So that's kind of how genetic engineering works. Now that poison doesn't hurt us. It's not a toxin that hurts us. Everything's poison. Everything's, all organisms are receptive to different things. So it's a poison that kills caterpillars, but it does nothing. It's probably in lots of our food, and it doesn't bother us whatsoever. All right. So that's slide 6. That gives you the gist of genetic engineering. And there was another example I wanted to give you. All right. So another example just off the top of my head is sunflowers. Sunflowers grow really, really fast. I don't know if you've ever grown sunflowers, but they grow real fast. You can get ones that go up to 12 feet high. They grow super fast. So do pumpkins, but let's just stick with sunflowers. So sunflowers grow real fast. Now, if we wanted to grow corn and wheat and some sort of crop very quickly, if scientists could take the sunflowers and look at the sunflower DNA and remove the genes that are responsible for making it grow so fast. Right now, it's very hard to figure out. There's millions and millions of genes. It's really hard to figure out how many or which gene controls this. And it's not always one. Sometimes it's 3 or 4 genes that control how fast it grows, right? But if scientists could isolate these genes, they could take these fast-growing genes, we'll call them, out of the sunflower, and they can incorporate them into other types of plants, and then those plants will grow faster. So our corn will grow faster, our rice will grow faster, whatever the case is. will grow a little bit quicker. So that's kind of what genetic engineering is, taking something beneficial out of one thing and put into another thing, right? And it works with animals too. And I think there's some examples here. But if you go to slide 8, you will see that there is a link, and that link will take you to 2 articles. Why is it no? Here it comes. So that the link will take you to 2 articles. I'm going to I clicked the link. So from slide 8, I'm clicking that link. The right-hand side, you will see two headings: weighing the GMO arguments for and weighing the GMO arguments against. So you'll see those 2 things. Those will bring you to the articles you have to read. So the first one is the pros, what people think are good about GMOs. The second one is what's bad about GMOs, right? So when I'm looking at the good ones, the 4, I see better resistance to stress, right? So if crops can be made more resistant to pests and to weather and to things like that, we could get more food. We could be more efficient at growing our food. And they already do this. They will take even the weather. So if they can find some plants survive longer into the winter, some plants can take the cold, right? So if you can take the genes that are responsible for keeping that plant alive longer in the season, and you can put them into our food supply, like wheat or corn or whatever, you could grow corn instead of just growing corn till, let's just say you can grow corn till October. You could now grow corn, well into November, December. You can grow more corn. So again, looking for a beneficial gene and putting it into things that we need that benefit from, right? I'm skipping around on these, but I see one that says more productive farm animals, right? This isn't just a plant thing. You can do it with animals as well. So there might be a gene that you can insert into cattle to raise their milk yield, to get them to produce more milk so you can get more milk out of them. All right. So they do these things. They see, okay, what would activate the cells that make the milk, blah, blah, blah. They can trick they can trick the cow's DNA into thinking that it needs to produce more milk, right? So some people say that's a good thing because we can get more milk. Scanning down here, more food from less land is on here. We talked about that Friday. You could produce more and efficiently, and you can get more food faster from the same spot of land. Impacts, bioremediation, longer shelf lives. You could put genes into things that will give vegetables, that will keep vegetables ripe longer and will not degrade too fast. We buy bananas for my son because he loves them, and they're like, they turn brown and I don't want to eat them within like 1 day, So if there was a way to insert a gene into bananas to keep them from dying and getting mushy so quick, that would be a very beneficial thing, right? I'm looking down here, vaccines and medicines, identification of allergens. I'll talk about that. But the vaccines and medicines towards the bottom of the page, a lot of the times we will take vaccines or we'll take medicines and we'll put them into plants and actually grow the vaccine in the plant and grow the vaccine or grow the medicine inside of the plant. So that plant itself is actually producing the vaccine for us. We do that with bacteria too. Bacteria make insulin for us. They just copy the DNA. We put an insulin gene in there and they start making insulin, and then we can harvest that insulin and we can use it. So there's ways to put vaccines and medicines into plants, and then the plants will just automatically make those as they're growing and doing their thing. So we don't have to make them in a lab. So that's interesting too. If I go to the against, so if I click on the other link to the other article and go weighing the GMO arguments against, that brings up some things that people think are not a good thing. Look through some. Looking at the third one down, sleeper genes could be accidentally switched on. Okay, in your DNA, you have a whole bunch of genes, and some of those genes are on and active, and some of them are sleeping or switched off, they call it, right? So some of them aren't on. You just have genes that are working, genes that are off. Throughout your life, sometimes those genes are switched on. Sometimes some of the genes that were on were switched off. That doesn't necessarily mean it's a bad thing. Sometimes it's a bad thing, sometimes it's not. But they don't know what could happen if they put a new gene inside. If they're trying to make the corn grow higher and they take the sunflower gene out that grows fast and they put it into the corn, That's beneficial, right? Because the corn will grow higher. But that new gene might turn another gene off or might turn more genes on that might change that corn and make it not as nutritious or do something to it, right? So you don't know what you're going to, when you put a foreign gene into something, some other DNA, you don't know what's going to happen. And you're hoping you get the result you want, but it could cause some sort of chain event that has a problem that can cause problems with the crop. So looking down here, transfer of genes. Okay. So I'm looking by the potential negative effects on human health. There's one of them that says transfer of allergenic genes, right? What could happen is you're taking a gene out of something and putting it in something else. When you take a gene out, you don't know all the proteins, the specific proteins that make that gene up. You don't know the specific protein sequence, or you're not really looking at. For instance, Brazil nuts. We know some people are allergic to different kinds of nuts, right? That is a very, very high frequency allergy. So there's something in Brazil nuts, there's something in peanuts, there's something in there that a lot of people are very, very allergic to. Now, we don't know. We haven't, I don't believe science has really pinpointed the exact proteins and the exact piece of the DNA and the exact gene that causes the allergy, or else we'd be able to get rid of it, right? But there was something beneficial in a Brazil nuts DNA that soybeans could use, right? So you take the gene that's helpful to the soybean, you take it out of the Brazil nut and you put it into the soybean, right? What you don't know, and what they didn't know in this case, was that in that gene that was beneficial for the soybean was a protein that's what people were allergic to. So what happened was, if I eat those soybeans, right, I don't know that there was Brazil nut DNA in it. When I eat those soybeans, that protein is in there. So I get allergic to that. And it looks like I'm allergic to the soybeans, but it's really the piece of DNA from the Brazil nut that they took out that I was allergic to. So there could be a lot of issues with that, with not knowing what the heck is really, we don't even know really what's in our food half the time anyway, but not knowing what's in the DNA of our food is even a tougher. So I'm going to let you read through these. There's a bunch of different ones, all right? But I'm going to go back to the slides real quick, because the last slide on here, again, this is slow. Okay, the last slide on here tells you independent practice. So I'm on slide 9. It says, pick a side. So I want you to read about them. You read about the GMOs from Friday. There were a couple articles if you need to look at those. You're looking at these 2 articles and you're picking a side. Do you think GMOs are good? Do you think they're not, right? A lot of people say GMOs are good because we can use science to create more food and feed more people. There's a lot of people in this world that are starving. A lot of people are against GMOs because once they get into our bodies, we have no idea what they're going to do. If they're going to set off a chain of events in our DNA, we don't know. What if remember that marker gene, the antibiotic that they stick to it? So here's the good gene they want, and they stick a marker gene to it, right? So when they put it in, they see if it goes in by adding antibiotics. What if that marker gene gets incorporated into our DNA? That would make us antibiotic resistant. That's bad, because when we get sick, we take antibiotics. What if those antibiotics didn't work because that marker gene incorporated somehow into our systems? So people are very scared of GMOs, and mostly because there hasn't been a lot of testing on them. But there hasn't been a lot of testing on them because they work really well, they work really fast, and they feed a lot of people. So I want you guys to read all this stuff. I want you to write me, one is too short. I want you to write me at least 2 paragraphs. This is going to get graded. You're going to write 2 paragraphs. So you're going to pick a stance, and you're going to say, I have 4 GMOs because. Okay, you're going to tell me why you're for GMOs, what really stands out to you. You're putting this in your own words, obviously. And then you're going to also tell me why you didn't choose the against, or, vice versa. So pick a side. Tell me why you picked that side. Tell me why you wouldn't agree with that. And that's it. That's what you're going to do. All right. So you are writing an essay. We'll call it 2 paragraphs. It's not an essay. And you are going to turn it in with these materials from today. Right? I'm did I finish period 5? No, I don't know. I'm finishing up putting the grades in, the rest of them, as soon as I get off my 2 classes, which is you guys and next period 6. So I'm going to go because I have another class soon. This gives you a half an hour now to look at that video, which was 12 minutes long, to understand genetic engineering as best as you can, and to start brainstorming some ideas for writing. We meet Friday. Today's Tuesday. We meet Thursday again, or I'll be on Thursday again. I think I'm going to try WebEx. That's another way to have a conversation. The only reason I've been doing YouTube is because YouTube records and nobody really, there's only a few people that pop on and say hello, which I appreciate. But most people watch it later. And I couldn't record anything to have it watch later unless it was YouTube. But now I heard that WebEx, you can record the meeting and people can go back and look at it later. So I might do WebEx. If I do WebEx, that means that you could actually pop on if you want and say hi and we can talk. But that's it. That's all I got. Go do your work. Go sign in. Go try to, oh my God, it's going to be beautiful today. So even if you stand outside for like 5 minutes, don't get near anyone. They say this is a dangerous couple of weeks. So don't do anything silly. Hopefully everybody's safe. It really sucks. I mean, it really sucks. I'm hearing from ex-students whose parent passed away from it. And it's very dangerous. We need to take it seriously. I have a couple ex-students that tested positive. So they're dealing with that right now. Just, keep doing what you're doing, being safe, and we'll get through it. But I will definitely chat with you later. See ya.